Sure.
All right, Lucy and Ashton. Lucy's in blue, Ashton is in black today. All right, make sure you have paper, pencil. And here we go. All right, reminder that you are to be working an hour a day in math. You're using the study guide and the checkup worksheets in Apex. And with those also what's the other step? Not only are you using the study guide and checkup worksheets, what's the piece that you want to do as a student? You want to self-assess your understanding by checking your answers. All right, here comes Noah. Noah in Algebra 1. Oh. Hello, hello, welcome. All right, Noah and Jimmy, welcome. You guys are both here for, who just left? Did they both just leave? It's so scary.
No, Jimmy's still here.
Oh,
No,
Jimmy's still here.
not
Oh,
left.
hey, Jimmy, you're here for Algebra 1, yeah? Awesome. All right, and then you're gonna check your answers, okay, with those answer keys. Answer keys, throw into the chat where your answer keys are for your Apex worksheets. Into the chat, where are the answer keys for your Apex worksheets? Hello, hello. Hi, Noah. Noah, you're here for an Algebra 1 lesson?
Oh, bye.
Bye, see you at noon. Are you here? Game clubs at noon. All right, Cornelio, here for Algebra 1 and Rueda, great to see you guys. Good, Jimmy and Ashton, that's right. Your answer keys for those worksheets are in files in Canvas. Beautiful. All right. Also, we have this new thing available to all students at Federal Way called tutor.com. It's open 24/7. Has anyone tried it yet? No? Okay, so if you're stuck and it's like off hours for me and you're not available, if you're not able to get a hold of me and you're stuck on the math, try tutor.com. Hi, Jasper. So your tutor.com is on your learn.fwps.org, your launch page, tutor.com. All right. One last thing before we get going. By now, everyone should have grades in your grade book. So go to your Algebra 1 class right now in Canvas and click on grades. There are 3 summative assessments that have been due. Anything in Canvas that says SA stands for summative assessment. And this is an assignment that goes into your grade book. The great thing about summative assessments is you can read the feedback, fix your mistakes, and turn it back in to be graded. Okay, and your highest score is what goes in the grade book. So put on your list right now, you're checking your grades. You're looking at grades in your Canvas math class. Put on your to-do list to redo any assessments with low scores. If you're missing something, it's been entered as a temporary 0 until you get it turned in. Okay, any questions about grades in this class? Go ahead and throw them in the chat, or you can unmute yourself and ask. All right, you guys ready to get going on the math then? Okay, if you're just coming in late, we want to make sure we have paper and pencil, and we're going to be doing math together. Okay. We're going to be going over lesson 2.1 today, solving multi-step linear equations. So we are in week 5 of our class. So when you look in your math class, week 5, your job is to do 2.1 and also 2.2. So this lesson right now is going to be over 2.1. Okay, so here's your objectives for this lesson. That you can isolate the variables in an equation by identifying the operations involved. Okay, this means you know what your process is. The second one, that you can collect like terms to simplify an equation. The third one, remember the order of operations to solve an equation. Identify equations that have no solution or an infinite number of solutions. And then lastly, turn real life problems into mathematical sentences and equations in one variable, and then solve the problem. All right, so today we are going to focus on these first 4. All right, and then at the end of this lesson, we're going to come back here and we're going to self-assess our ability to meet these objectives. All right, let's get this math party started. Oops, that was right. Okay, we are dealing with multi-stepped equations here. And so here's 2 examples here on the right side of your screen. Go ahead and get those written down in your notes. So your notes should say 2.1 because that's the name of our lesson. And then go ahead and write down these 2 problems. We're going to do these together. Number 1 and number 2. So number 1, -10 equals 3x plus 2. Number 2, 21 minus 5x equals 16. And we're going to do those together here. Before we do that, I want to show you an animation that we have in our math book that helps. Let's see, if you were a math book, where would you be hiding? You would be hiding right here. So solving equations is a review topic, meaning we've seen it before. And so your job in this lesson is to fill in the holes. So remind yourself of your understanding, practice, and improve on your skills. All right, thumbs up if you can see our math textbook here. You can use the, and what are they called? Emotions, emoticons, what are those things? All right, thank you, Lucy. All right. So we are solving this animation down at the bottom. Shows the solution of 2x plus 4 equals 12. So right now, before we solve this in the animation, go ahead and mentally figure out, see if you can mentally determine 2 times what number plus 4 equals 12. See if you can do that mentally. You can throw it into the chat. Awesome. Jimmy, we're going to go back and look at the problems again. Oh, thanks, Lucy, for throwing those up there. All right. So you have mentally, think you have an idea of what it is? All right, let's watch this animation. So we're trying to figure out the value of X. So notice by balancing, they're taking off the same amounts from each side. So they just took one away from each side and then another one away from each side. Okay, so what's left at this point? What do we have on the left side? Or I should say, what's remaining? We have a 2x on the left side. What's remaining on the right side? Eight. And so we can put them into two groups. And there's that last step, divide by 2. So each x then was equal to 4 units. So let's watch that again. So we first get rid of the units they have in common on each side. Then we're going to break up into the 2 parts in this case. Get x isolated. Good. Notice the words up here, it says undo the addition, undo the multiplication. What's that idea called when we undo something in algebra? Awesome, Jimmy. Thank you. Yep, inverse operations. And so we're going to be using inverse operations here as we go through. All right. I also like to think of this as our variable is in the middle of the onion. Who's ever sliced an onion before? Or peeled an onion? There's many, many, many layers to it. So if you want to envision your variable is in the middle of that onion, in order to get your variable isolated, you have to first work from the outside and you work your way in. So if you hear me say peel the onion, that means you're going to be peeling away the outside layers first. All right, let's look at this first one together. Ooh, and how'd that go, Jimmy? Was it comedic? Did I say that right? Red onion or white onion? Yeah, I bet you cried. All right, let's look at this first one together. So we're going to use our inverse operations. We want to get our variable isolated. So I'm going to circle what I want to get isolated. So we want to peel the onion. So you just look at the right side here. What's farthest away from your x here? The +2 or the -3? What's on the outer layer if you're thinking of it as? If we're thinking of this as an onion, nice, I'm seeing in the chat box, that +2 needs to get out of there first. So what's the inverse operation of +2? Nice. So inverse operation of +2 is -2. So let's subtract 2 from both sides. That goes away. -10 minus 2. So you have -$10 in your bank account and then you go down $2 more. Oh man, we're going in the wrong direction, aren't we? All right, that leaves us with -12 equals 3x. All right, last step. What undoes 3 times x? What's the inverse operation? Nice, I'm seeing it in the chat. Division, divide both sides by 3. Good, Ashton, you like your final answer still? Yes, you got it. All right, remember how I asked everyone to have a calculator at the beginning? Because at this point in your math career, that calculator is a resource. So I'd like you to take your -4 and substitute it into our original equation and make sure that -4 is actually a solution. So you're going to do 3 times -4. And then add 2. And we want to get a -10. Green check mark. You verified. -4 is our solution. Good. Lucy, I noticed that you got number 2 and you got it correctly. Would you like to work that one out for us, Lucy? We can crowdsource steps for you if you'd like to do that, or you could just do it yourself. What do you think?
I mean, I just knew it because, like, there's no really other answer it could be, because just 21 minus 5 is 16.
Awesome. So you did it mentally.
Yeah.
Love that. Good. Okay. And you're absolutely right. 1 is the value of X that makes this true. Perfect. Okay. So now our job is to solve it algebraically. Algebraically. Hi, Elijah. Welcome. All right. So for number 2 here, if we wanted to get our X variable alone, we're peeling the onion. What's farther away from X? Is it this 21 or is it the -5? What one are we going to get rid of first? Because we want to isolate that variable. I have crickets in my chat box. Awesome, Rueda. Rueda said 21 is farthest away. Exactly right. Well, how are we going to get rid of 21? What's the inverse operation? Good, Jimmy. So right now, 21 is over on the left side. We want to move it. We want to get it away from the same side as the X. So if we're not sure, just try something and see if it works. So what if we subtracted 21? Is 21 minus 21, does that go away to 0? Yeah, we think so. What if your guess was first to add 21 as the inverse operation? Let's see what happens here. What's 21 plus 21? Does that go away to 0, or does that cause more of a mess? Yeah, notice this would go to 42. It would go to 42. Does that help us at all? Have we gotten rid of the 21? No, 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 no. But do you see what I did here? I didn't know what to do, so I tried something. Good. Okay, so what's the inverse operation then? Is it addition or is it subtraction in this case? For the 21 only. We're only talking about that 21. So are we going to subtract 21 here, or are we going to add 21? Love it, Ashton. Good. Rueda said subtraction. Jimmy said subtraction. And what we do to one side, we do to the other. Beautiful. Okay. What is left over on the left side? What is remaining? So 21 minus 21, see ya. We are remaining this 5x, but what do you also spy here? You guys ever played the I Spy with My Little Eye game? I spy a negative 5x left. Give me a thumbs up if you also spied that there was a negative 5x left. Good. All right, Ashton, what's left on that right side? 16 minus 21. You can throw it in there. All right, well, Ashton's simplifying the right side. In the chat, what is our next step? We have -5 times x. I want to get that x isolated. What's the inverse operation that undoes multiplication? What undoes multiplication? Good, I'm seeing some things in the chat. Beautiful, division. All right, Ashton, why don't you just take us home? Go ahead and show dividing both sides by -5. And Lucy, are you liking our final answer? Rueda, does it look like we're gonna get that final answer that we were looking for from the beginning? So we're dividing both sides by -5. -5 divided by 5 is 1. Thanks for verifying there. Good. Oh, are you done? Final answer is 1. Good. I'm gonna just show a little bit more work. I'm a math teacher. That's what I do. Good. Divide both sides by -5 equals. Good. So final answer on this is going to be a +1. So double check your work, because a -5 divided by -5 is a +1. Good. All right. Speaking of being a math teacher, hey, that's a really good Halloween costume, wouldn't you guys say? Was anyone looking for ideas? No? Crickets again. Crickets. All right, you guys ready to do some more math? Let's do it. Ashton, thanks for writing on the screen. Anyone else interested in writing on the screen? You are, you can be the scribe for this. Anyone else? Okay, let me know if you want to be the scribe on this page. All right, Ashton, are you up for the challenge here? Awesome. Okay, before we fill in these terms, so this screenshot right here was taken from your study guide for 2.1. And I did that to show you how important those study guides are. So where did my, come on. I wish my screen was bigger. So this is from the 2.1.1 study guide worksheet. All right. Before we order these, so we're how to solve multi-step linear equations. Before we do these, I want us to look at this example over here. Let's call this number 3, since we've already done 2 problems together. Go ahead and write that problem down on your notes, in your notes. We have -2 plus 2 times the quantity of, that just means in parentheses, x minus 6 equals 4 minus 1. Okay, there are definite rules by which we want to follow what we do first, what we do next, what we do last when we're solving these multi-step equations. So let's look at this together to help us figure out which of these steps on the left is the first, is the second, is the third. Okay, so for number 3 here, are we able to combine any like terms here? Can we combine like terms or collect like terms yet? Is there anything that we can collect yet? I see some no's, I see some yeses. So Ashton, you said no. Can you unmute yourself and tell us why there's no like terms here?
This isn't for like terms, like, wouldn't that be like, let's just say, see the -2 on the left side?
Mhm.
Let's just say that was -2x. Wouldn't that be added to the x in x minus 3? So then it would be -3x, I mean, -1x.
Mm-hmm. So for example, you're saying 2x and x would be like terms and we can collect them.
Yeah, but we don't have that.
but we don't have that, or you don't see that. Cool. Good. Jimmy, what about you? You said, yes, we do have like terms. Never mind. Okay. Well, there are some like terms here, which is hard. Look at your right side. Ah, good. Yeah. Look at that right side. There are some like terms. We could combine 4 and 1, right? 4 minus 1. Good. But Jimmy brings up a good point. We have some numbers that are trapped inside parentheses. So really the first thing we have to do here is we have to do the distributive property. So step number 1, we are going to distribute that 2 to both pieces on the inside of that parentheses. So guess what? Ashton, number that is number 1 over there for us, please. Do you guys know who Vanna White is?
Wait, what did you want me to do?
Use the distributive property to get rid of parentheses. That is step number 1. Could you put a 1 over there? Does anybody watch Wheel of Fortune? All right, that's a little bit of homework for you to do before next Tuesday. Down here at the bottom, Ashton, number 1, use the distributive property. There you go. Thank you. All right, so first step is distributive property. Always, if there is something to do. So we're going to distribute that 2 through. I'm going to change my color here because purple has a lot of going on. So we're going to do 2 times x, and then we're going to do 2 times -6. Rewrite what you now have for our problem. -2 plus 2x. 2 times -6 is -12 or -12. And rewrite what you have. Thumbs up when you're good, you've distributed, you're ready for the next step. Ashton, go ahead.
I was wondering why for 4 minus 1, I was wondering why we switch to 4 plus 1.
Because your math teacher is a little crazy. That was a mistake. Good catch. Thank you, thank you. Thank you, great catch. Okay. Number 1, distributive property. Make sure you have that in your notes somewhere. That is the first step. Second step. Now, does anybody spy some like terms on each side of the equation that we could simplify? So you're going to combine like terms on the left side, and then you're going to combine like terms on the right side. Good. All right. On the left side, what are our like terms? We have 2 numbers that we can combine on the left side. Good. Cornelio, Lucy, Jasper, Elijah. What are our like terms on that left side? You can throw your thoughts into the chat, or you can unmute. Nice. I'm seeing some things in the chat come through as -2 and -12 are like terms. Okay, so combine those. What do we have? We have -$2 in our bank account, and then we go down 12 more. Again, wrong direction, huh? All right, so it gives us -14. I still have that plus 2x. All right, equals. What do we have on the right side after we combine our like terms? 4 minus 1. Good. Trace. Okay. Notice I have thrown a line down the middle of our problem, which is a strategy for you to try as you're solving these problems to keep the 2 sides separated. So you want to combine like terms on each side. All right, Ashton, did you throw in a 2 up there on the screen for second step? Combine like, collect like terms. Good. I don't like that. We like saying combine like terms. That means the same things. Okay, look at the last step. Only one available. Use inverse operations to isolate the variable, okay? Or, in other words, peel your onion and get your variable alone. All right, so this is the work we just did together. So what's the first thing we want to get rid of there on the left side? Do we want to undo the minus 14 or do we want to undo the 2 times x? Go ahead and put into the chat what's the first thing we want to do, or you can unmute yourself. I see 2 votes so far that we want to get rid of the negative 14 first. Wait a minute, Jimmy, you can't vote twice. All right, anyone else? Oh, no, you didn't vote twice. I just see it's in there twice. Only one idea? So we're going to get rid of negative 14 first. Are we sure? Okay. So negative 14 is farthest away from the x. So I agree. That's the first thing we're going to get rid of. How do we get rid of it? What is the inverse operation? So right now it's like a negative 14. What are we going to do to both sides to move it over to the right side? Again, if you don't know, try something. You could add 14. Let's see what happens there. Negative 14 plus 14 go to 0. Okay, so that one worked, right? Good. We tried something and it worked. Thank you, Ashton. All right, so adding 14 to both sides. Good. 2x equals. What are we left with on the right side? 17. Beautiful. All right, last step. What's the final inverse operation to get x by itself? What undoes times 2? All right, I want to see my chat blown up right now, or you can write on the screen. I want to see participation from everybody somehow. What is the last step to get x by itself? Yeah, Lucy. Yep, Jimmy. Yep. Ashton looks good. Do we agree with what Ashton is doing on the screen? He is dividing both sides by 2. Thumbs up if you agree. Do we have a thumbs down? Emoticon. What do we have? Good. Some thumbs up. Good. All right, final answer. X equals what? Beautiful. X equals 8.5. You can leave it as 17 halves if you want, or you could simplify it as the decimal. Both of these are great final answers. All right. And so our third step then is to use inverse operations to isolate your variable. Good. All right, thumbs up if I can erase the screen and we're ready to move on to the next. Thanks, Jimmy. All right, Lucy, Jasper, Elijah, Rueda, Cornelio. Can I erase the screen? You still writing stuff down? Okay. Oh, Fergus. Wayward clicking. Wayward clicking will do that. Okay, so let's look at these problems that are in your study guide. Okay. Okay, does anyone else want to write on the screen? Ashton's been doing an amazing job. Lucy, Jimmy, Rueda, Jasper, Elijah, any of you guys want to write? You can also ask people to tell you what to do. You have the power. Okay, does anyone want to tell me what to write? Okay, so let's look at number 1. So the only difference here is we're going to do these problems. Go ahead and get them written down in your notes. And then we want to check your answer by substituting it back into the equation. So listen, there is no excuse at this point for getting a wrong answer for equations because you can always check your answers. All right, let's look at number 1. So reminder of the steps. First step is to distribute. Step 2, combine like terms. Step 3, isolate variable. All right, I see a note. All right, good. Lucy, you have an answer for number 1, substitute it into the original and see if your answer works. If it does, then you got it. All right. Step 1, distribute. There's something here to distribute. That 5 is going to apply to both the x and the -1. Go ahead and rewrite what you have after distributing. 5x minus 5 plus 3 equals 13. Okay, and I'm going to draw a line down the middle there. Okay, so we distributed, check. Next, combine like terms. What like terms do we have on number 1? Any like terms on the left side? I spy a -5 and a +3. What is that? What is that? Nice. So we have 5x then -2 equals 13. Okay, are there any other like terms for us to combine on number 1? Nope. Notice how I wrote the steps and I'm using them as a checklist. Great strategy for you as you're doing these problems, especially until you get your own fluency down. Last step, isolate the variable. Let's peel the onion. All right, what's farther away from the x, the -2 or the ×5? Good, the -2. What undoes a -2? What's the inverse operation? Love this participation in the chat. Good. Add 2 to both sides. -2 plus 2 goes to 0. See ya. Final line here. We're left with 5x equals 13 plus 2. Good. People are telling me to, last step here, 5 times x. Good. Lucy, do you like your final answer that you got? I'm going to divide both sides here by 5. Final answer, x equals Nice. Rueda, yes. Okay. We think it is x equals 3, but how can we be sure? By checking our work. So now we're going to substitute in 3 and for x into our original. I totally knew what you meant, Ashton. I really did. All right. So we are going to do 5 times, and I'm going to substitute in 3 wherever I see an x. 3 minus 1 plus 3 equals 13. Actually take the time to go through and check your work. Okay. Let's now simplify this with our order of operations. Order of operations always trumps everything. Order of ops. So 3 minus 1 is 2, because we got to do our parentheses. Okay. Good. I'm getting verifications that people like our final answer. And then we need to do multiplication. So 5 times 2 plus 3. Spy game again. I spy with my little eye. Ashton, go ahead. 13 equals 13.
So the way I did it from the top, pretty sure it still probably comes out the same, but I did 5, like for the very, very top one, I distributed 5 to 3 and 1, so I did 15 minus 5, which came
Good.
out to 10, and then I added that to 3.
Beautiful. Good. So typically, if you have actual numbers on the inside here, you can save yourself that step of distributing through to both of the real numbers by just simplifying what's in the parentheses first. But yes, you're right. You get the same answer either way. We have to distribute if we don't know what these numbers are, both of them, like over here.
Okay.
But that's awesome that you verified it works that way too. Woohoo! All right. Big old POTB, everybody. POTB stands for pat on the back. POTB, pat on the back. All right. Let's look at number 2, and then we are in a good place to pause, and I'll work with people with individual questions. Okay. Number 2. So get this problem written down, and I'm going to use a different color so I can use that checklist. Lucy, is it okay if I use blue? I know you picked blue earlier. All right. So our problem is negative 2x plus, in parentheses, 12 minus 9 equals 2 plus 9 plus 2x. All right. First step says distribute. Now, there are parentheses here, but this is a trick question. It's making sure you understand what these parentheses mean. Notice there's nothing touching the parentheses, and even more so, we actually know what's inside. We know the quantities, the values inside. So there's no distribution in this problem. It might look like it at first because we have parentheses. That's right. So, all right, we did that one. Next step, combine like terms. What are the like terms here? And we have like terms on both sides. Both sides of our equal sign. Ashton, go ahead and write on there if you would like to. So we have things that we can combine on both sides. Beautiful. So we have a 2 plus 9 on the right side and a 12 minus 9 on the right side. Good. I'll do it just to save time. How's that? Thank you for identifying those. So we have a negative 2x plus 3. All right. If you worked ahead, Double check that your first line matches our line. Negative 2x plus 3 equals 11 plus 2x. Good. We did combine like terms. Okay. Now, I am noticing on number 2, I have x values on both sides. Well, this is new to us. We haven't talked about this yet. Notice we have x terms on both sides. So in order for us to combine these together, they need to be on the same side. So we are going to use inverse operations to move one to join the other. Inverse operations. So let's move this leftmost one over to the right side. So I have negative 2x. The inverse operation is to add 2x. So let's add 2x to both sides. All right, and we are left with 3 on the left side equals, go ahead, Ashton. What's 2x plus 2x? So we have 11 plus 4x. Because there's our like terms, 2x plus 2x. Good. Okay, peel your onion, get x by itself at this point. Notice we have our x's on one side, and now we need to isolate. Good. Thanks for doing that checklist for us, Ashton. All right, do I get rid of this 11 or do I get rid of the 4 first? What's farther away on the outside layer? Good, I see in the chat that 11 is farther away. Okay, do I want to add 11 to both sides or do I want to subtract 11 from both sides? You can test it. 11 plus 11 goes to 22. So that doesn't get rid of it. So what if I subtracted 11 from both sides? Does that? Nice. Good, Jimmy. Subtract 11 from both sides. Good. So 11 minus 11 will go away. 3 minus 11 is what we have on the left side. 3 minus 11 is a negative 8. Equals 4x. Last step, divide both sides by, what's the inverse operation of times? 4 times x. All right, division. So divide both sides by 4. Final answer. X equals -2. Nice, Rueda. Nice, Jimmy. Good. Good. Thank you, Ashton. Good. Okay. Now we need to check our work. So let's take this -2 and we're going to substitute it into both parts in our original where we saw x. So we're going to have -2 times -2. And this is on, I think your next summative assessment is you solving an equation and then also substituting it in and illustrating that it works as a solution. All right. So substitute it in. And then we want to follow order of operations to simplify both sides. So inside parentheses, that's going to be a 3. -2 times -2 is a +4. On the right side here, we have multiplication we need to take care of first. 2 times -2 is a -4 or a plus -4. All right, and then keep simplifying. 4 plus 3 is 7. The left side is 7. 2 plus 9 is 11 minus 4. Ooh, 7 equals 7. Ding, 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 ding. That is true. Therefore, what we substituted in. Woohoo! True statement. Therefore, that X value that we substituted in is the solution. Is the solution. Okay. So here's what we're going to do. We are going to go back to those objectives. This is not quite enough for you to be ready to take the quiz. At this point, you want to finish the lesson. All right. But we have a good start. So I want everybody to write on the screen here, and you can leave it anonymous, but I'd like you to self-assess on these top three objectives. Where are you right now on each of those? And so either your green means you got it, yellow, kinda following along, I need to do some more practice. Red is, I have no idea what you're talking about. So like a stop sign. So you're gonna take over and write on here by, oh, Ashton, could you unmute yourself and tell us again how students can write on the screen?
So pretty much all you have to do is, so all you have to do is bring your cursor up to the top of the screen, and it should say you are viewing Kim Fergus's screen. And if you press on, let me check what it says. Press view options. It should pop up in a thing, and you can press annotate, and then it pops up a bar for you to click on a